Today we are going to be looking at the Results law. The calculations we have there has to do with Graham's law. Sorry, not the results. Graham's law of diffusion, which states that the rate of diffusion of gases, the rate of diffusion of gases is inversely proportional to the square root of its vapor density, and it's also um, inversely proportional to the square root of the relative molecular mass. So this is what we're going to be looking at. That means rate is inversely proportional to square root of its vapor density, D. So the same law also stated, since we know that the relationship between the vapor density, that is 2 times vapor density, 2 times vapor density will give us a relative molecular mass. So in that case, we can also express rate of diffusion in terms of vapor relative molecular mass, in the sense that relative molecular mass, rate of the diffusion is something as 1 square root inversely proportional to what? Relative molecular mass. Relative molecular mass. That is what it also means. So if you are here today, we are going to be looking at some questions, and we want to encourage you to keep up with us as we dive through some of the calculations. So here we have some questions here that we are going to be looking at. The first question here says that 100 cm cube of methane diffuses through a porous plug in 30 seconds. How long will it take 200 cm cube of oxygen to diffuse through the same porous plug under the same conditions? Now, the options we have: A is 60 seconds, B is 75 seconds, C is 85 seconds, and D is 90 seconds. Now, this is dealing with time. It's dealing with time, but the rate of diffusion, we know that rate is equal to volume over time, or perhaps mass over time, as the case may be, because it has to do with rate. Now, but then in this case, since we have seconds, there's another way we can still get this thing done. It's either we use this relationship, this relation we have, volume over time equal to rate, or alternatively we can go by the law, stating the law in another way. In terms of time, rate of diffusion of gases, according to Graham's law, sorry, why am I calling the results here? According to Graham's law, time of diffusion is directly proportional to what? Vapor density. Time is also directly proportional to relative molecular mass. So what it means that since we have the time and we don't have we have the volume, and we're looking for the time, because say how long, that means we are looking for the time. The time is what we're interested in. So if we are comparing two gases, so the first gas, the time for diffusion of the first gas, we can say is T1. The second gas can be T2. That means what we have here should be something that will look like this: T1 over what? Square root of T1 molar mass, or relative molecular mass, of T2 altogether will give us this. So in that case, we have this. But now we are going to know the volume: 200 cm cube of oxygen. The time it will take 200 cm cube of oxygen. But what we have here is the time it took 100 cm cube of methane to pass through porous plug is what? 30 seconds. Now, before we can do this calculation, we need to find how long it will take the same volume of oxygen or methane to pass the same porous port. That is one thing you should also note here. How will we do that? First thing, we have to find out that. Let's see how we're going to get this thing done. We have, that means, what's wrong with my 100 cm cube of methane equal to 30 seconds. That means 200 cm cube of methane will then take 30 seconds over 100 times 200 over 1. So what it will take will be 2 times 30 will give us 60 seconds. That is equal volume of methane will take 60 seconds to pass through the same porous spot. Now we have the 60 seconds already here stand by for us. So the next thing we are going to do is to then compare the gases in order to compare the rate of diffusion, their diffusion time, in order to get exactly what it will take for the oxygen to diffuse, 200 cm cube of oxygen to diffuse. Then we can go back to our, you can say that this is for oxygen, time for oxygen, this is time for methane, then equal to square root of the relative molecular mass all over square root of also relative molecular mass of what? Methane. This is for oxygen, since they are directly proportional. So we can substitute whatever we want. We're looking for the time for this. Then we don't know this one. We don't know it. Okay. Then methane is what? The time for diffusion is what? 60 seconds. Remember, we have a 60 seconds. Then the other one, the relative molecular mass of oxygen is a diatomic. Diatomic. So what it means is that 2 times 16 will give us 32. That means what we have here, square root of what? 32. And then methane, we have methane, that is carbon is 12, hydrogen is 1, but hydrogen is 4 in methane. That means 4 times 12, everything will give us about 16. Then 16 squared. So that's what we have here. So the next thing we do here, what I'm going to do, take the square both sides, square here. What we have is, and then 60 squared equal to, this one will give us 32 over 16. 16 can cancel, we have 2. So if we are going by this is 1, this is 2. If we are going by what we have here, for the oxygen T squared, time for the oxygen is T squared equal to 2 times 60 squared. 2 times 60 squared. So let me just use calculator to make it faster. This 60 squared times 2, what we have here will be 7200 equal to T squared substitute the oxygen. So the next thing is taking the square root of that. We have, so the square root of this, that will give us 7. If we square it, square root of that will give us square root of answer. We have, what we have here will be 84.8 approximately. That means approximately you have 84.5 seconds. That is the correct answer here is what? C, which is 85, approximately 85. So the next question here says that a given volume of oxygen diffused through a porous plug in 8 seconds. How long will it take the same volume of sulphur 4 oxide to diffuse through under the same condition? Now in this one, we still the time we are looking at. We are looking at time. But meanwhile, the questions you are solving here now will be in the description of this very video you're watching. So I want to encourage you, make sure you subscribe and share, and then If you have any question, leave it in the comment section. We will always, oh, I will always attend to you. All right, let's continue. So this one we have options. We have here: A is 5.7 seconds, B is 8 seconds, C is 11.3 seconds, and D is what 16 seconds. So in the same vein, we still have this one, and then T1, T2, and then what are we using? Okay, you can still use the molecular mass. So since they are directly proportional, everything can still remain the same, like the other one we solved. So here, what are we doing? We can say that this T1 is for what? Is for the oxygen, that is 8. Know that T1 for the oxygen is 8 seconds, and the time for sulfur 4, which we don't know, we call it T2. Then the relative molecular mass of oxygen being diatomic is now 16 times 2. That will give us square root of 32 all over that of sulfur 4. We have sulfur is 32, and then plus oxygen, which is sulfur 4 oxygen 2 times will give us 32 plus 32. That should be about, that is 64 all squared. So I believe that you know how to calculate the molar masses of all these relative molecular masses by adding up all the values. Look at it. For this one, sulfur is known to be 32, and this one 2 times 16, because oxygen is 2 here. 2 times 16, that will give us 30, 32. Adding it together, we'll get 41. So let's quickly go back to what we're solving. As we have already stated here, if we take the square root of this place, square here and square there, the square root will go off. We have 8 squared and t squared equal to, this one will give us 32 all over 64. This will cancel 1. That will 32 will cancel this. We have a 2. So cross multiplying, we have T2 equal to 2 times 8 squared. 8 squared will give us, I think it should be 64. Yeah, 64 will give us 64 times 2 times 2. We have 128. 60 square root is still there. So square is there. And then the next one we're doing here, to get the square root of this, in order to remove that square there, so square root of this 128 will give us, square root of that will give us 11.3 seconds. That is what it will take us. Now, thank you so much for being part of this class. And you can see from this, this calculation is something very easy. It's something that you can, cool down once you give your time to it. It's very, very easy to understand. Thank you so much for being part of the class. And we have other related calculations video on this under our playlist, which I will leave in the comment section of this, and I will encourage you to go through there so that you will be able to upgrade your level in these calculations. Thank you so much.